Hi, this is Ben from Fixitgearware Security, and today we are here with the Programming Thursday series. In today's episode, we'll be talking about the introduction to programming. The essence is to enable you to understand the fundamentals, as these are criteria for you to understand what a tool, speaking from the cybersecurity term, to build, and what component of an infrastructure, network, or computer that this tool is targeting. So without much time wasting, let's get into today's episode. What is programming, if you may ask? Programming can be understood as the concept of writing a series of small to huge codes to make up a program. The objective of programming is to design codes that are capable of solving even the most complex algorithm into a simple one. For example, let's consider AI, which is a machine-based program trained with a large data sets to solve problems based on the program pattern and make decisions based on that. What is a program or computer program? A program are a logical set of rules. These rules are logically related. Their relationships are in a sequential order. The objective is to instruct the computer in solving computational problems, for example, calculators and web application. Speaking of logically related, now comes the question, how do I understand logical relationship in codes? Let's give an example. The sum of two values a and b can be denoted as a plus b. You then might ask, how are they logically related? To be able to obtain the sum of these two values, an operator needs to be introduced. In this case, the plus symbol. And without the plus symbol, there is no way these two values can relate with each other. So in that case, when we say the sum of a and b, we are trying to introduce the logical relationship, which is the plus symbol. So A and B can now be said to be logically related by the plus symbol or operator. Also, we have to understand computational problems. You might be asking, how does this web application solve these computational problems? Consider, for example, when you try to log in into a web portal, you supply a password, right? This web application have to make a logical computation, checking if the plain text value of the email value supplied is equal to the email value stored in the database. And it then checks the corresponding hashed value of the password supplied if it's equal to the hashed value of the password stored in the database. If these values have been verified by their logical relationship, or if they are logically related, the user is then granted access to the website's users panel. So in this essence, the logical relationship is assigned with the operator equals or the equal symbol. So if the value of the email is equal to the value of the email in the database, and the hash value of the password supplied by the user is equal to the hashed value of the password stored in the database, the user is then connected to the users panel of the web application. Another example of computational problems on web application is when you purchase something in an online store. The program does the total sum of the product cost, the value of the taxes, and shipping cost, which then is presented to the user of that online store of the total cost to be paid for the said product. So let's say you try to purchase an item from Walmart, eBay, Lazada, Shopee, or whatever online store you use, or Jumia. You say, okay, I want to buy an iPhone, and the iPhone costs about, let's say, $10, right? And the shipping cost for the product is like $5, and the taxes is like $2. So the web application will do this computational formula or calculation based on the underlying code on the web application. So 10 plus 5 plus 2 will become 17. And the user or the buyer of such product will now be presented with the sum of the total cost of this product. Moving on to the next, how can a computer program be acquired, you might ask? One, as a packaged software. This is by either purchasing these softwares from developers or freelance programmers, or secondly, by custom-built software involving the developing or writing codes from the scratch, tailored to the demand and specific tasks expected of the program being able to solve. The first, as a packaged software, like APIs, when you go to Twitter or X or Facebook or any other social platform or service provider trying to connect to their server to retrieve certain informations to either verify users on your platform or for other business purposes. These are prepackaged softwares known as APIs, Application Programming Interface. So basically, when you sync this API to your back end of your code and you try to call the vendor of that application whose API you're using, you have said to have used a packaged software. So it has already been developed by the vendor or the owner of the API you're trying to use to connect to your own application. Without that, there is no way you can be able to verify any vital information, either be ID, users' names and passwords, or other OAuth verifications on your platform. So as a custom built software, basically this is you building your own application. We have different types of custom built softwares, either CRM, mobile applications, and so on. So writing a program as a custom built software involves you building that software itself to work or sync with the purpose of which the program was written for. Next, you now ask yourself, what are system softwares? So when we talk about system, basically we're talking about computers. It can be desktop, it can be a laptop, it can even be a tablet, it can even be a phone. These are all systems because they have a certain functions they perform. So let's try to understand what the system softwares are. They are a group or collection of programs written, and they are designed to execute a computer hardware and application software of that particular computer. So basically, when you try to open your laptop, the OS, for example, is the system software. Without the OS pre-installed on the computer, there is no way you can be able to use that computer. Like without the OS, the computer is like a zombie. So this is how system softwares are to be understood. Without the system software, the computer is just a hardware component without any use. So let's try to now understand examples of system softwares. One, as we said previously, we have the OS, which stands for operating system. A very important part and necessity that keeps a computer running or in operation is the operating system. Most operating systems are built as bootable. For example, the Windows. Without the Windows operating system installed on your computer, there is no way your computer can have a UI, which is known as the user's interface, because there is nothing to boot on or boot to. While others are built as file system structure. For example, we have the Linux, where we have the root tree, we have other directories such as the user, the bin, and so on. The OS is responsible for scheduling many jobs that are to be executed and manages the computer resources. So for example, when you're trying to open your Microsoft Word document on your computer and your Notepad and do some other stuff while running these applications, like for example, you're trying to use your browser as well. So this OS is responsible in scheduling these jobs. For you're running all these jobs at the same time, the operating system is going to pause the ones that are not very important and serve the current one that is being requested. So without the operating system, there is no way these programs can work. And without the functionality of scheduling the jobs, that means every program will have to run at the same time, which of course at the end of the day crashes the computer. Another example of system softwares are the shell and terminals. Users can interact with the operating system via the shell. The shell is also responsible in facilitating the opening and closing of system application. For example, you can use the shell to launch an application via the Windows. Also on Linux, for example, if you install a tool such as application scanning tools, vulnerability scanning tools, you have to run a series of commands for the UI of that tool to be accessible. The shell is not just basically just a shell. It's also a terminal to communicate to the operating system and facilitate the opening of any application that is being requested. Also, if you're into designing codes or writing codes, you should know that to be able to connect to GitHub, an online repository designed by Microsoft, you need the terminal, which is of course the shell. So installing the shell is how you remotely push and pull to your repository. And also you have to install the SSH keys, which are primarily configured on your computer hardware or storage drive installed on the computer. So the next thing is the device driver. The device driver, they are programs responsible for controlling the operations of a particular type of device that is attached to a computer. So for example, when you attach a microphone, headset, or even an external drive to your computer, these drivers are what are going to read those external components and verify if the hardware is compatible with the computer. In some cases, drivers are out of date. The computer might read the hardware component that is plugged to it, but there will be a problem of having optimum functionality of that hardware. Also, the device driver are very essential because without the device driver, you cannot be able to use an external drive. It's like you just have a computer that has an operating system, right? But what can it do? Nothing. Because to be able to run your browser, you need a driver to be installed. To be able to play an online media, you need the sound card or audio driver to be installed. So these are very essential. Without the driver, the computer also is useless or cannot be useful for human use or any other forms of operation. The next of system software is the middleware. So they serve as a gap between the OS or the computer OS and the application running on the OS. So an example of the middleware is the system kernel. It's considered the heart, part of the heart of the computer. Sometimes it's confusing to understand what the kernel and CPU is. So the kernel is like, how do I say this? You have, for instance, you have the browser, right? And you install this browser on your computer. While you try to launch the browser, the kernel is going to communicate this to the operating system that, hey, Mr. A wants to launch the browser. Now the operating system will do whatever underlying function it's designed to do, and of course supply the answer by opening the application. Next are utility softwares. So these are necessary to ensure the managing, fine-tuning of the computer and application softwares. These utility can be pre-built, for example, the disk fragment utility found on the Windows computer, software update library, which is responsible in checking for Windows system updates, the system cleanup, which is also responsible for cleaning the hard disks or cache files on the system. And we have the MDA, which is the Microsoft Defender's antivirus, which scans for active malware on the computer system. Other forms of utility softwares are the ones that can be installed by the users. They are like third-party optimizers such as Fogtet, AVG TuneUp, and CC Cleaners. So these are third-party applications which are not pre-built by the Windows operating systems, but they are also considered as utility software. You can install them and make use of them on your computer. So the essence of giving you this basic knowledge or introduction is that when you write exploit codes, by understanding memory addresses and how these addresses can be exploited, these are the components of the system software you will be trying to exploit or look for vulnerabilities in. For example, the operating system, you might be looking out for how you can exploit the memory addresses and all that. And for the shell, how to obtain a shell command, you also have to know these basics so that when you write a payload or an exploit code, you will be able to understand what actually the code is doing. For example, a simple PHP script that launches the C command on a computer system or launches the terminal on a web server. So you have to understand these basics of what programming is. When you now supply these codes, you understand what part of the component you are trying to attack. Other forms of system softwares also that can be exploited includes the device drivers, the middleware, the utility softwares. Without this knowledge, there is no way you can understand the functionality of how the code you're trying to write works or examine the exploit code you're trying to deploy works. So it's very important that you know this, and that's why we decided to dive into this introduction. And next week, we'll be commencing a description of C. As we said, we are going to make these videos to be 10 minutes short, going straight to the point in those codes, explaining the inside and outside of these codes. But this is not the full course. It's just a way of understanding the basic programming functions, such as writing a simple code, writing a function, understanding what polymorphism is, iterations, what else? Conditional statements. What else again? Encapsulations, and many other forms, many other functions in programming language. So basically we'll be dropping this like it's going to be a 10 minutes short videos, because programming is not something that you should just teach in hours. We are not here to show our skills that we can program. We are here to teach you the foundational skills, how you can understand the program, how you can logically design your own program to run clean codes and reusable codes. So basically clean codes are codes that are very easy to understand, and reusable codes are codes that can be used by any other person for the same purpose which the code was designed for. So you don't want to write a code that is designed to exploit a Windows computer, and when it's run on a Windows computer, it doesn't work. But when you run it on your own system, it works. So you have to understand this concept, and that's the reason why we are taking this foundational approach. There's a lot of programming courses out there which have done amazing jobs, but that is not the essence of us writing or developing or shooting content that has to do with voluminous course structure of programming. The essence of our own course is to teach you the foundational structure. Then you can now understand how to read a memory address, how to write pointers to that memory address, how to exploit, how to force with these codes, and writing your own test script. Because if you don't understand how this works, there is no way you can be able to write your own code that's even clean, yet alone to be reusable. You should know when a conditional statement of if is applicable and a perfect choice. You should understand where a conditional statement switch is perfect and a recommended choice. You should know when you should design a function overloading, and so on. So these are the concepts we are going to be teaching you, making it short as we promised, and at the end of the day, you'll be able to understand and be able to build your own stuff. However, our premium course will go in depth. We'll be demonstrating this. And the essence of why we cut this to be short videos teaching you the foundations is because we're also trying to abide by the rules and guidelines of YouTube. We do not want to write an exploit code that might result to the banning of our channel. That's not the essence of us teaching you this. We are teaching you the foundational stuff. You understand how to pinpoint this, how to write the stuff. Then you, if you're very, 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 very smart enough or a prodigy, you can understand what we're trying to do and start thinking of how to write your own code privately. But if you still are confused that we're only giving you the foundational knowledge, do not be scared. Do not be worried. We'll also be providing our premium courses where we'll be going in depth, showing you the structure of this code. And also, as we promised, we are not just going to be talking about C. We are going to be talking about C++, Python, Bash script, and PHP. We wouldn't be going into Java because Java is complex, and we're not teaching you Java on our basic programming courses, which is the free ones we'll post here on YouTube. So that's it for this week's episode. We have finally come to an end of today's episodes. Please do not forget to give the likes by pressing the thumbs up button, and do not forget to subscribe by tapping the subscribe button while ensuring the notification bell is turned on to be the first to get notified when we post a new topic. Once again, thanks for watching, and see you next week on another episode of Coding with Fixitgearware Security. Bye.